Hello, welcome to Building a Graphical IDE in Elm and Purescript. I am Claudia Doppioslash. I'm a functional programmer and a game developer, and I write on Lambda about functional programming. And I work for Parasitic and GmbH when we do cool stuff with embedded Erlang, mainly for industrial control in the automotive industry, like stuff like this, smart conveyor belts, which actually run Erlang. And we also do an embedded board that runs Erlang or any other Erlang-based languages, like Elixir or LFE. So why might you be here? Well, the first option is you want to get some front-end code done and you hate JavaScript. Anyone? Yes, that's a popular one. You might also be interested in Haskell-like languages in general, or undecided between Elm and Purescript, in which case I hope I'll give you some data points to make your decision today. What you are getting is a work in progress mortem. So basically, the project is not finished yet, but we have made choices and we changed our mind. So I'll tell you what went right and what went wrong, and our experience of porting from Elm to Purescript as well. But this won't be an Elm or Purescript guide, and this is not the latest Elm version. It's actually Elm 0.16, because there was a jump between 0.16 and 0.17 where they got rid of all the things in that column over there. So if I mention any of those and I've done that and you don't know about them, don't worry, you're not supposed to know about them anymore. So our project is a visual IDE for an interesting language, a PLC language with that nice memorable name, IEC, blah, 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 numbers. Stuff like that. And PLC means Programmable Logic Controller. They are computers used in industrial automation. And they sort of followed a parallel universe version of evolution because they standardize on function block, which is the block over there. On the top, there are the events, and on the bottom, there are variables. And the IDEs that are usually used in the industry right now look like that on the left. But we wanted to do something a bit more special for our IDE, so we were inspired by Brett Victor's talk, Inventing on Principle. If you haven't seen it, I suggest you do, because it's really cool. And that those graphs down there are taken from that talk, and this is our project. So I think you can see some similarity on the left column. And I'm going to explain exactly how this works, because there are a lot of layers involved, compilers and embedded stuff. So basically, we start with a PLC language program, which is then compiled into Beam files. And then the Beam runs on bare metal, on the hardware. And also Cowboy runs with it. Cowboy is a web server for Erlang, which talks to the program and sends debug information to our IDE. We had a few requirements for this project, mainly it should be cross-platform. We needed to support all PLC OSs and also the iPad Pro. And the performance needed to be at least interactive. So 30 FPS would be good, and we were going to show a lot of graphs. So that required some thought. But we decided to go with web technologies because it's the easiest way to go cross-platform without having to rewrite everything all the time. So there will be JavaScript, CSS, and SVG, possibly. But, you know, JavaScript, let's not do that. So we didn't. And back then, we had a few choices for a language that compiles to JavaScript that actually is usable. So we had ClojureScript and CoffeeScript and Elm and TypeScript. And I think you know which one we chose out of those. We chose Elm. But why did we choose Elm? Did we choose Elm? Well, the main reason was functional reactive programming, the paradigm around which it used to be based. And we were into it, and we basically chose it for that reason. And also the good error messages, the famous good error messages that Elm has, that was certainly better than undefined is not a type. And also some concepts were somewhat similar to Erlang, like mailboxes. They're not quite the same, but it was nice that there were some similar keywords, and we thought it might be more similar than it turned out to be. So what is Elm? What's a good description of Elm? It's basically a purely functional, strongly typed, eagerly evaluated language that compiles to JavaScript. And it used to be based around functional reactive programming, which is now gone. And it also has Haskell-like syntax, but without the strange squiggles like the starship operators, trained sequences of characters that are a bit odd without those. And it's also a very small language, very self-contained. And that makes it better optimized for learning curves. So there is not that much language to learn, so you learn it quicker. Also, it's similar to Haskell in many ways, but it doesn't have any advanced type, like higher kind of types, type classes, none of that. The pros that Elm has compared to JavaScript are quite a few. Well, the main one is if it compiles, it works 90% of the time. That actually is the real thing. And also, you can be very confident while refactoring because you can just make your change, and then you'll get error messages, and then you can fix them one by one. And at the end, it just works. Almost no thought involved. It just works. It's also a very clean language, and it's more expressive, so you don't need as many lines of code to do the same thing you would do in JavaScript. And also the famous great error messages were a pro. About those actually work so well because they don't send you to look at the line 359 of your code and figure out what the hell you were doing. They just show you the piece of code that they're complaining about. And then if it has one of the simple errors that it's prepared to suggest you a solution to, you will also get the solution to your error. And how do they do that? Because great error messages are not really common, even though they're getting more common because other languages are getting inspired by it, like Rust is adopting that, and also even GHC is trying to adopt that. So how do they do it? Well, they made it a priority at the very beginning of the project. So they had a public Git repository to track strange error messages, and then they would fix them in the next compiler version. So actually, a lot of effort went into it. And also, you have less type system complexity compared to something like Haskell or Purescript. So if your type system is a bit simpler, it's easier to have good error messages. And also, in Elm 0.16, there was something that was a bit of a problem with the type errors, which is if you want to do, say you have a function. You define this function. It's got a type signatures. You use it 50 times, but the 51st time you actually make an error with it. And you would think, I want the compiler to tell me where that place where I called it wrong is. But actually, sometimes it will tell you the definition is wrong. So you would be left to go through all those 551 instances of the called function by yourself, which is not ideal. They might have fixed that, though. And also, I don't know if you've seen the VAT talk about JavaScript. Someone has. So Elm actually makes sense as a language, while JavaScript, at the time of that talk, array 16 would give you 16 commas in JavaScript. No idea why. And there are also a few cons compared to JavaScript. For example, JavaScript interoperability is it's not very flexible. If you need to wrap some big JavaScript library like T3, that's going to be fairly painful. And also, it's a new language. It's still 0.x. So you might want to be aware of that. But all in all, there wasn't that much. So we went ahead with it. And I'm going to explain to you a bit more about the project structure, which is fairly complicated. So we have the PLC board, and the Beam is running on it. And it's running the PLC program, and the Cowboy Erlang web server, and the Bullet WebSocket library for Cowboy. And they talk to each other, and they send information to WebSocket, to the browser, which is running the Elm application, which is getting through the Bullet client is getting the WebSocket information from the Bullet server, and through ports is talking to the Elm Rung WebSocket library, a custom library, which then talks to the PLC IDE program. And now I'll show you the PLC IDE program, hopefully. And it's a bit small. Yeah. As you can see, the function blocks that you've seen before. On the top, there are events which are firing. And on the bottom of each function block, there are variables which are changing. And this is a semaphore program, so it's got a red, a yellow, and a green. You can just click on the variables, and it will show you all the values in the last 60 seconds or so. And as you can see, the green and the red never overlap, which is the point of a semaphore. But the yellow does a little bit, and you can just see that out of the plots over there. And that was the main point of doing this special IDE. Right, moving on. So that program there has this structure. So as you know, we got a PLC device, and then we have a WebSocket component, which we called Elm, which is separate from the decoder component. So the WebSocket component gets the JSON API and then sends it to the decoder, which decodes it and sends it to the renderer, which keeps the state of everything and renders to the browser, where you will have UI interaction that will get sent to the encoder, which will encode JSON and then send it back through the WebSocket library to the device and then get an answer back. And that is not the usual way Elm programs are built right now, but it was our own version. So each of those components is what used to be called startup, which is basically the Elm architecture. That was the implementation of the Elm architecture for Elm 0.16 as a library, which is a bit different from what is now the Elm language and the Elm architecture. And the pieces which are in more are mailboxes and addresses here. So this is 0.16. But it works like this. So basically you have, the model is the state, and you have an update function to which you also give the model and the action, and calculates the next state of your program, and then renders that with the view function, and that gets any browser input and make an action out of it, which is then addressed to the proper component and received through the mailbox. So you have this action that you got from the browser, and you then calculate the next state of the program on it. So this app, as you know, was made of 4 components, which were 4 components made of startup, connected by different mailboxes. And we wired them into a parent startup, so they're actually nested. And this is an interesting structure invented by the GitHub user Fox Donut, which we chose because it was very easy to expand. We wanted to be flexible and be able to add components when we wanted to. But it was never ported to 0.17 because it really relied heavily on FRP. And you could probably port it, but it wouldn't be as elegant anymore. It wouldn't be as nice to develop it, so we didn't really bother. And also our WebSocket library can be a component using this structure, but it would be awkward to port it to the new Elm. So that's the main reason we are still on 0.16. The actual main reason is that it works. So that's good. It didn't stop working. We also use FRP very heavily, and the project it was a client project, so it had a limited budget, and we didn't want to spend a lot of budget porting to a new version of Elm, which we might then port again to another new version of Elm, so we sort of stopped there. And we were frustrated about lack of communication because the 0.16 to 0.17 change didn't really have any deprecation warnings. They just did a short alpha phase of like a couple of weeks, and that was it, and it was too late for us to change our direction. So we're waiting for Elm Evolution to stabilize before looking at it again. I'll probably go over a few production problems we solved while we were making this app. Like how to organize subcomponents in a big Elm application. So the structure we use, the file structure we use is from that structure that we adopted. And it's fairly straightforward because it's got an action, model, and view and update file, one for each of those. And then it's got a feature file where you wire up all of that together. And then to wire up to the main startup, you have another file which we called app.elm. And then you can get that startup that you wired in to the main Elm, and that will then wire it everything and it will run. Also, another interesting question was how to mix Elm and Elm project, because if you have many Elm projects which maybe have each one Elm app, you want to, what do you do? Do you keep different repositories? Do you mix them? What do you do? What we ended up doing is having an Elm subdirectory in the Elm project. So we could compile the Elm files to priv, and then we would just add the resulting JS file to the HTML, and that worked pretty well for us. And another thing that maybe is not often mentioned is if you're Elm, if you have an Elm package that you want to put on the Elm package repositories wherever all the packages are, if it's got JavaScript in it, you can't put it there. They won't allow you. So we couldn't put a libraries with JavaScript over there, so you have to have your own different solution. What we ended up doing was having it in the repos, as I said before, and then you fetch it, and you have to store it in the subdirectory of not the Elm project, but the Erlang project, one app. And then you can move only the Elm files to a subdirectory of the Elm project, but not under Elm stuff, because that's where Elm package put its own libraries, and that would mess it up horribly, which has happened. And then you can include that subdirectory you created in the Elm package JSON, and that is the most straightforward way I know to do this. Now, well, moving on, I'll talk a bit about the rendering. As you saw, we have a fair bit of plots and graphs and stuff that we're rendering. There were a few choices for that. We could have gone the HTML way, which would have been awkward. And another option was making our own 2D rendering engine in WebGL, which would have been really cool, but that probably would have taken quite a lot of time. And so what we ended up doing is using SVG, also because SVG library is really good. And the choice there was, do you do the styles and the animation in CSS, or do you do them in Elm? And we went with SVG with CSS, because doing animation in Elm, you can do it, it works, but it's a bit awkward. You have to keep a lot of state around, and that's what CSS is for. So you want to use it for that. So we just keep our CSS styles in a separate CSS files. We don't mix them with the Elm at all. And then we have CSX and SVG expert on call, which I recommend. So anytime CSS is acting up, you just ask her. Solves a lot of problems. One thing I want to say about Elm HTML and Elm SVG is that they have, I think, great syntax. As you can see there, it's, even if the first time you saw them ever, you can still tell where is the tag, where are the attributes, where are the nested tags. So I think that was very nice. And it's also, both are based on virtual DOM, so they are very fast. You can see benchmarks online. There are a few, and they are quite fast. So summing up our Elm experience is, if you want to make an Elm program, you should be aware of what Elm is good for, specifically what the Elm architecture is good for, because an Elm program has to fit the Elm architecture. There are no more escape patches now, which is very good if your app fits, because then everything is straightforward. You don't have 30 frameworks from which to choose from and get bogged down in decision. But then if it doesn't fit, then you can't get out of it. So that's not good. So be aware. If you're aware, everything will be fine. And if you want to wrap JavaScript libraries, big JavaScript libraries like D3, you probably don't want to use Elm, because, as I said, there is no path to get your wrapper on the Elm package, and then no one will use it, and then everything is quite awkward. Also, if you use ports, I don't know, who here has used Elm? Okay, the interoperability is called ports, and it's quite limited because you only have this port is basically you can send data to Elm and send data back to JavaScript, but it has to be of a certain type that you declare. And so you have to have a different port for each of those that you want, which tends to be pretty long if you're wrapping a big thing. And also, Elm is still experimental, as 0.16 to 0.17 proved. There haven't been since big changes, so 0.17 and 0.18 are still pretty similar. So maybe there won't be any more big changes. Who knows? I don't know. But be prepared to rewrite some code. And also, Elm lacks a roadmap. It's all in Elm's author mind, which is great, but it's a bit less great if you want to make predictions and know if you're going to write stuff. But still, it's a 0.x language. There are short beta previews, and you can keep up with them and the changes by subscribing to the Elm dev mailing list. So what's next? We have skipped over Elm 0.16, 0.17, and 0.18, and maybe we'll come back when Elm is nearer to 1.0 and more stable. But meanwhile, we're going to take another language for a spin and do something with it. And now we have more choices. Compared to the time we started this project, there are also Reason, BuckleScript, Fable, Purescript. They are breeding like rabbits. So it's ever more important to choose wisely or rewrite everything yet again. Our first choice was Elm. So Elm basically was saying, please adopt me. I swear I won't mention monad. Everything will be easy. And it's true to a degree, but after you've used Elm for a while, you might want to break free out of those limits, which makes your life easier, but also harder in some ways. So we chose Purescript, which frees you up. You say, you can do whatever. If you can make it type check, it's up to you. But then there are many more choices and much more freedom. So I will tell you a bit about Purescript. Purescript is a purely functional, strongly typed, evenly evaluated language that compiles to JavaScript. Where have you heard that before? Here starts the differences. You got many advanced types. You got higher kind of types. You got type classes, monads, functors, applicatives, a lot of stuff. It also uses the Haskell-like syntax still, but with all the squiggles. Actually, they're pretty enthusiastic about squiggles. So you got your starship operators and all of that. But there is also a way to deal with that that makes it easier. And I must say, I wasn't really much into squiggles, but now that I'm used to them, they do work and they are quite concise. So you should probably just invest the time to get used to them. One other difference from Elm is that it has no runtime. And they built it on the JavaScript semantics and added types on top. So it generates readable JavaScript. And you can almost turk in your JavaScript and then change it if you want to. And that should work without driving you crazy. And also, it's got a nice community. It's not big, but it's open. And there's a bit of a roadmap, which helps. So to summarize the philosophy differences between Elm and Purescript, with Elm, the main priority is to have a smooth learning curve and be able to learn it fast and keep things simple. While in Purescript, they're always adding new stuff. And they do take care that the stuff makes sense. They just don't add things for the sake of it. But you should be prepared to have a longer learning curve and to learn the nice abstractions, things that maybe you put off before. And another thing is, Elm doesn't really give you any choices, which is nice if you just want to get something done. You only have one possible program structure. You only have the Elm HTML library, so it keeps you really focused on what you want to do. While in Purescript, there are many possible ways of structuring your apps, and many libraries and many choices, which we're going to go over a little bit now. So you might ask yourself, why Purescript after Elm? The trade-off that Elm makes is quite interesting. By keeping the type simple, but still using the type concepts from Haskell, it keeps the learning curve smooth, but it also gives you more boilerplate, because you can't abstract some stuff out that you could in Haskell or Purescript. And also, the component business is a bit awkward, where it's a bit nicer in other things. So you might want to keep that in mind. So the main thing for me was the types in Elm are quite nice. I like them. Coming from some functional programming in Clojure, it's actually surprising how much I like them. And so more types, yay, let's do that. And they also have more features. So simplicity versus power, you have to choose your poison. At this point in time, I choose power. Also because once you've done like a year of Elm or maybe 2 years of Elm, you're starting to get bored of the boilerplate. I have. So you're likely to be able and ready to reach for higher abstractions to get rid of that boilerplate. Also, it's similar enough that I don't have to rewrite every single character in the code base, like I probably would have had to if I had chosen ClojureScript as a second language. Also, an interesting thing is it's possible to implement Elm in Purescript as a library, and someone has done it, Elm 0.16, but you can't do it the other way around because of the limits that we were talking about before. One nice thing about Purescript is that it benefits from following Haskell from a distance. So the people that develop new stuff in Haskell, they try out stuff, and something is cool, maybe something less cool, and in Purescript they do stuff with a bit of a time delay, so they know what is cool and they implement that. For example, the type class hierarchy in Purescript, they were able to implement it right the first time around because they learned from Haskell. While I think Haskell is still having a bit of time trying to fix it without breaking all the code before. And another nice thing is the community is small but open, and the communication still works. So some pros compared to Elm are, well, Pursuit is a search engine for types. So you have all the source code of the Purescript libraries you can search through by type signatures or also by function name. So if you have a Starship operator and you're wondering what the hell is this and how do I import it, you just put it in Pursuit and it will tell you what library to import and all the documentation for it and what it is. So that's really great. And Elm has got something like that with Elm package. They got some search, but it's not over everything. And it's not, I don't think it's by type. And someone implemented Hoogle for Elm, I think, but I'm not sure if they're still working on that. Also, it's got a clear direction, as I mentioned. And one surprising thing is you can work a lot with the REPL if you want, because you can't really in Elm because you're relying on the runtime. And in the REPL, you don't have the cycle of the Elm architecture to drive stuff. But in the Purescript REPL, you can do everything yourself. So if you want, you can build a program from start to finish, at least a small one, within the REPL. And it's also got a really nice multi-line mode. And another great thing is the workflow. I use Emacs, and the workflow for Emacs is really great. You can have type holes, which were recently introduced, but they are really good because if you don't know the type of something, you just ask the compiler, please tell me. And it will not only tell you the type of something that you want to write, not only tell you, but it will tell you what function in the libraries that you have imported will fit that type hole. So you can just basically ask the compiler and you can stick the answer in your code. And also you have, as we mentioned, many cool abstractions and stuff. But it also takes a lot of time to learn the cool abstractions, so that is the main con. And I might inflict on you 3 reflections on the relationship between Elm, Purescript, and Haskell now. Flee if you don't want to. So Elm is the simplest language out of the 3. It's focused on development user experience, which there are not many languages that do that. So you have one way to do things. And they are quite merciless with all historical baggage. They just get rid of it. People don't use it. We introduce a feature. People don't use it. It's gone. Next version is gone, which keeps the language small. And I think it makes a great entry-level language into this world of purely functional, statically typed languages. While compared to that, Purescript is a bit more focused on, they do worry about developer user experience, but they're not obsessed about it. They also like to implement powerful stuff, even if maybe it's not so obvious how to use it. But you can still figure it out. And I think it adopts a very sensible way of doing things, and it's very practical. Maybe more practical than stuff in Haskell, because Haskell is a research language. So the point is to research new stuff, and this new stuff might pay off or not. So UX is not really a worry usually. And they also need to keep a lot of backwards compatibility because of historical baggage, and that makes it a bit harder to have good developer UX in Haskell. So if you go from, say, Elm, you start from that, you get used to the syntax, you get used to the types, you get used to the purity, and then go on to Purescript, you get the abstractions, higher-kinded types, but it's still eagerly evaluated because, and that's helpful because you don't have to worry about laziness. While when you go to Haskell then, at this point, you already know a lot of that there is to know about Haskell, just by having learned the 2 before. But you also add laziness when you're ready for it. So I think that makes the most sense as a sequence. And another difference is that Elm only targets web browsers now, not even Node.js, so you can't make servers with it. While Purescript has got many backends, C++, Erlang, and obviously JavaScript. And Haskell compiles to a lot of stuff. That's it. So I hope this makes you want to try Purescript. And if you want to try Purescript, at the moment, the package manager is Power, though that they which is a JavaScript ecosystem package manager. But they are working on a new one specific for Purescript. So when you use Bower, though, when there is a new version of Purescript, Bower isn't really aware of it. So it will try to install versions of libraries that don't go together. So don't be discouraged if you are in one of those times, because after a little while, say a few weeks, all the libraries will be updated, and then you will be ready to go. Even if nothing works, just sit tight. It is going to pass. So now I'm going to do a bit of a framework overview in Purescript. There are a bunch of choices, and the main difference between them, a bunch of them is wrapping React, and a bunch of them is just Purescript. And I'm going to show them to you here in a graph according to type complexity. So you have the easy ones, like Flare and Pux, which is our implementation of the Elm architecture, basically. There are the lenses one, which are Thermite and Optic UI, and there are the free monads one, which is Halogen. So why would you want to use Flare? Flare is a really nice little library that's very easy to start with to make like cool interactive graphs, like interactive tables, interactive plots, and it's really nice and straightforward and a great way to start doing something in Purescript and have some result without learning a lot. The limits are that there is only one use case if you want to make interactive graphs. But it also doesn't require a lot of knowledge. If you just can cope with inter-applicative functor syntax, you are ready to go. You don't have to learn a lot of other stuff, which I think is useful. And then Pux. As I said, Pux is similar to the Elm architecture. For us, an advantage would be that the SVG support is already included through React. And also a nice thing is that you can use the interactive React debugger, which is a bit like the Elm time travel debugger, which is really nice. And it's probably the simplest Purescript framework that you can make web apps with. But the reason I don't like to use it is React dependencies. I mean, I will take a moment to whine about installing React. When you try to install React, it's like installing tools forever. Like, what is it doing? And when I was trying this, GitHub was having problems. So the installing would fail, and then I would have to start from the beginning, which was very painful. And to show you that the Pux structure is really like the Elm architecture, below there is the Elm architecture, and above there is the Pux structure. And as you can see, model is called state, and that's about it. Everything else is almost the same. And also effects. You have effects in Elm 0.16, but in Purescript you use the effect types here, which are F and AF and others. In fact, they are so similar that I will give you a quiz. I'll keep this for 5 seconds, and then I'll show one is Pux and one is Elm, and then you can tell me which one is Pux, which one is Elm. So 5, 4, 3, 2, 1, and next 5, 4, 3, 2, 1. Which one was Elm?
The second one.
Yes. Well, I skipped over that. Yeah, the second. Good. But it was similar, wasn't it? So moving on, we have the lenses ones. I'm afraid I don't know much about lenses. But if you like lenses, there are 2 options here. Thermite wraps React, and it's written by Phil Freeman, which is the author of Purescript. And Optic UI is made just in Purescript. So you have a choice there, if that's what you like. So now we're going to talk a little bit about Halogen. Here be free monads. So Halogen doesn't have any Java, it doesn't wrap anything, it's just Purescript. So that is really good for me, so I don't have to install React for 100 years. It's also used in production by Lambda, which is a commercial company which makes a rather complex web application, which is rather impressive, actually. So there are a bunch of people developing it all the time, and people pay them for the product that they produce with it, which I think is excellent if you want to do something like that. And there is almost version 1.0, almost there. So that also is nice. And they kept making it better and make the types less complex. So it's actually getting less complex as it goes on. And you might not want to do it if you don't want to worry about types too much. For that, probably you want to use Pux. And Halogen Structure, compared to the Elm architecture is still pretty similar. Model is state, action is divided in two different types of actions. One is just action, and then the other one is request from the state of the component. You also have a component type, which is nice, so you can actually reason about it instead of just have it in your head. And update is called eval, and that's where the free monads are. And render is called view. Also, you have to wire the inputs in main, just the way you would do it with any Purescript program, and effects are still the Purescript effects, and there are a bunch of Halogen effects. But all in all, it's still pretty similar. And I will say that Halogen HTML syntax is really nice too, and in fact, it's almost the same as the Elm HTML syntax, which is nice. And I will show you a very simple component, which just has a button that when clicked changes a Boolean. That's it. So at the top, you can see the state, which is just state type, which is just Boolean. And then you have the query definition, which is just a union type. And then you have the component definition, which is vaguely reminiscent of how you wire the startup library, I mean the Elm architecture. So you have an initial state, render, and eval, and you pass them to the component. So, and you have an initial state, and you have the render function, which in this case is just render this button when on or off, depending on the state. And then here you have the eval function, which is update, to which where you have the case, where you interpret which one of the two commands you can give it. So I think that's, I mean, there's more code than maybe the Elm one, but it's still fairly straightforward, at least for such simple example. And it's still, you can see the similarity of it. So I hope I got you interested in Purescript and also Elm. And to get started with Purescript, I will suggest a few steps to do it. You should get it from NPM, or you can get PSVM, which is a version manager, and then install the version you want from that. And also, you should probably read Purescript by example, unless you already know Haskell. But even if you already know Haskell, it will show you what is different from Haskell. Which is the book written by Phil Freeman, which is the author of Purescript, and it's free online. And if you come from Elm, you should probably read the library Purescript Compact Elm, which is the library used by that Elm implementation in Purescript. Because it will show you how you do the same things as Elm in Purescript, like tuples are different and stuff like that. It's actually quite useful. Then you could try out Pux or Flare, and you could visit the Purescript channel on Freenode, or come to the online video meetup, which I think is monthly or twice a month. And then you could try out Halogen and free monads and stuff, make your web app, and profit. That's how it usually works. So my conclusion for Purescript is that it's a powerful language. It's also a sensible language. I tend to agree with most of the choices they make, which is nice. It's got all the abstraction you might want. Well, not all of them, but most of them. And it will take you some learning. It will take some time to learn, but if you already know Elm, it will be quicker. But also, one thing to keep in mind is you don't have to learn everything. You don't have to learn free monads on the first day. Just take Flare, give it a spin. That's how I started. And that's actually nice enough, and will probably make you want to learn more. And even though it's not obsessing about having the greatest user experience ever, it's still a good user experience because it's a sensible language. So we are at the summary between Elm and Purescript, and also considering working with Erlang. Elm works well with Erlang, and also Purescript works well with Erlang, and it even compiles to Erlang. And if it compiles it, it will work. It compiles your code, it will work, and also Purescript is the same. In Elm, boilerplate can get a bit repetitive, and in Purescript, types can get complicated and complex. And in Elm, we should never expect to have advanced types, like high-handed types, because there was at some point talk of implementing type classes, but that's not going to happen, most likely. And in Purescript, we should expect to have a bit of a learning curve. If you get started with Flare and then go on, it will take you a while, but it should be fairly pleasant, actually. In Elm, you have Haskell syntax without the squiggles. In Purescript, you have Haskell syntax in all its squiggly glory. And there is really no roadmap for Elm except the one that is in the author's mind, while in Purescript you have a bit of a roadmap. And you can also ask in the channel, they're really nice and they will answer you. And so I think that Elm is a great entry language into, purely functional statically typed languages. If you come from, even from functional programming, but not statically typed. And Purescript is a great second step. So that's it. Oh, yeah, one more thing. I don't know if you came to Pers Talk yesterday, but as I said before, we make hardware boards that run Erlang. So if you want one, you can subscribe to the mailing list, and you can win one from a raffle until the 12th of February. And that's all.
Thank you for the talk. So you didn't actually say, I think, which framework you end up using for your app.
Halogen.
OK, thanks.
I'm pretty happy about it, too.
We are going up.
Thanks. Thanks for the talk. You mentioned that you relied heavily on functional reactive programming from Elm on the initial version, 0.16. Yeah. It would make any difference now with 0.18, like your decision?
Well, 0.18 didn't really change much. They tidied up a bit. They removed some stuff that people weren't using, and even some stuff that people were using, actually. And I don't know.
I feel like they dropped the functional reactive programming bit.
Yeah, I don't think it's ever going to come back, to be honest.
Okay, so we are going up.
So you convinced me to try Purescript after having some experiences with Elm. And now I have two questions, which are, firstly, you mentioned that you used custom solution for wiring up your application in 0.16. And my question is, wasn't the startup enough for your solution? And the second question is that this boilerplate and wrappers in Elm happens to be like safety net, which prevents runtime errors. And my question is it really worth it? I mean, did you have any problems with JavaScript interop on the TypeScript side of things?
One at a time, please. So what was the first one? My memory.
So the first one was, why did you use a custom solution instead of startup in 0.16?
We are actually using startup. Just every component. Remember that 4-component graph? Each one of them is a startup. But then you have to wrap it up again in another startup that contains all of them.
Yeah, exactly. But you've also said that there was a custom solution, and you mentioned
that is the custom solution.
That was the custom solution.
There's a fair bit of wiring up all the bits to do that. Yes.
Oh, I see now. So couldn't you simply use those 4 components as nested in this one startup instead of using 4 of them?
Yeah, but it also depends. It also depends on what you wanted to do to start with, because we started with the idea that this was similar to Erlang, so we said, oh, we should do things as we do in Erlang.
Or like an application model. I see.
So we went that very different components, very separate from each other, which is totally different from one single source of truth. The two things don't really work with each other, which is why I use Halogen now, because it's not one single source of truth. So it makes sense for us, for the frame of mind that we use, basically. But it's your choice. You can make things work either way.
Yeah, thanks. That makes sense. And the second question was about those wrappers in Elm, because in theory they should give you some more safety. However, did you have any
ports?
Yeah, the ports.
They do give you a lot of safety that you wouldn't get otherwise. It depends. Even then, it depends on your use case. If you want to use D3, wrapping D3 with ports, I think it's going to be a bit of work. It just doesn't really work that well. While with Purescript, for example, you can basically use the code. The interoperability is everywhere. You can use it for everywhere. Also, in 0.16, you can only interop on the main file. So you can imagine having to send the information from the main file down to the subcomponents. That was a lot of work at the time. But you don't have to do that anymore now. You can use ports everywhere. So that's something that only is for 0.16.
And on the TypeScript side of things, when you do this interop, have you encountered any errors?
You mean Purescript?
Like, for example, specifying the wrong type in Purescript for the JavaScript library. Is it possible?
I haven't really done much with it yet. There probably is, because there is no type checking of the JavaScript part, so you will likely have a runtime error. But I've only used library wrapped by other people.
Ah, okay.
Other people's wrapper.
I see.
Basically.
Thank you very much.